Alright, this is lecture 1.4, which corresponds to section 2.5 from the textbook. And this is probably one of the most important lectures of the entire semester, and it's a lecture over quadratic equations. So this is going to be huge. The contents of this lecture we're going to be utilizing throughout the entire course, and you will utilize frequently throughout pre-calculus and in calculus. So we're going to open up with a very important solving strategy, and that is solving by factoring. And we can do this thanks to something called the zero product property. And the zero product property is rather intuitive. It states if A times B equals 0, then that can only be a true statement if either A is 0 or B is 0 or both of them are 0. Well, one of them has to be 0. So 0 is a very special number in that if a product equals 0, some part of that product has to be 0. So it's a very unique property, and we can use that to solve. So the idea with solving by factoring is we can set the equation to 0, factor everything, and then apply the zero product property. So we're going to go ahead and do that in problem 1 right now. Notice everything is factored. So this statement can only be true if either x is 0 or x minus 8 is 0 or x plus 2 is 0 or 3x minus 5 is 0, or x to the 2/3 minus 4 is 0. So if a product equals 0, then one of the factors has to equal 0. It's the only way it could be true. So we'll just solve each one of these. So the first one's already solved. The second equation gives us a solution of 8. The third gives us a solution of -2. The fourth gives us a solution of 5/3. And then this last one is a power equation. Notice an even power equation, just like on the first homework assignment, so don't forget the plus or minus. That's going to be 8. So we can see that we get a variety of solutions to this equation. We get 0, 8, -2, 5/3, and then plus or minus 8 as a solution, all by applying that zero product property. Now it's very important that everything is factored to apply this property, and it's very important that it's set to 0. So if you look at number 2, notice this product is not set equal to 0. So the factoring is actually kind of useless here. You might think, well, if something times something equals 9, then those numbers have to be either 1 times 9 or 3 times 3, because those are the only factors of 9. Well, you'd be incorrect. There's actually an infinite number of numbers that multiply to 9. You know, I could have 2 times 9 halves, 4 times 9 fourths, 7 times 9 sevenths, 11 times 9 elevenths. Those are all numbers that multiply to 9. So there's actually an infinite number of numbers that multiply to 9. So that's why we don't have a special property we can use here. But 0 is very special in that if two numbers multiply to 0, one of them has to be 0. So what we want to do here is go ahead and multiply out, or what we like to call FOIL. So multiply that out, you get x squared plus 2x minus 15 equals 9 when you multiply to 0. And then what we want to go ahead and do is set it to 0. So that's going to get us x squared plus 2x minus 24 equals 0. And then we're going to go ahead and factor. So when we factor that, we get x, 6 and 4 will do the trick, plus 6, x minus 4 equals 0. So either x plus 6 is 0 or x minus 4 is 0. And we get two solutions, -6 and +4. And you can indeed plug this back into the original statement. They will work. So let's go ahead and introduce our second strategy for solving quadratics, the square root property. So the square root property states if x squared equals c, then x equals plus or minus square root of c. And the main thing here is, don't forget, at plus or minus whenever you use the square root property. This is just a specific application of power equations. So if you square root both sides, you need a plus or minus. So here we don't set it to 0. What we want to do is isolate the squared value. So we can subtract 4 from both sides and then square root both sides. So square root the left, square root the right, don't forget the plus or minus, and note we get a pair of complex solutions. So this is why we covered complex numbers in the last section. So just a heads up, complex solutions will always come in a pair. They will always come in a pair, so that's why you need that plus or minus. Now here, in example number 2, note that the quantity x minus 3 is squared, so if we isolate that, we can use square roots to cancel out the squaring. So that's exactly what we're going to do. So we can subtract 5 from both sides, and then we want to go ahead and divide both sides by 2, and we get 3. Now what we did there was we isolated the squared expression. That's what we're doing when we apply the square root properties. We're isolating that squared expression. And then we can go ahead and square root both sides, and when we do, the squaring cancel out with the square root as intended. Don't forget the plus or minus, so we get plus or minus square root of 3, and then we just need to add 3 to both sides. So 3 plus or minus square root of 3. There's our 2 solutions right there. So the square root property is great. So the square root property is ideal if all variables or all unknown values are inside of a squared expression. Alright, so let's go ahead and look at the quadratic formula, our last solving strategy for solving quadratic equations. And if you have a standard quadratic, i.e. ax squared plus bx plus c, where a, b, and c are real coefficients such that a is non-zero, then you have that solution. Now, if you move on to a pre-calculus class, you will need this formula memorized. So if you are moving on from college algebra to a more advanced mathematics class, you're going to want to get this one memorized. But let's go ahead and apply it. And note, what we want to do to apply the quadratic formula, if you look at the formula, it is set to 0. So we do need to go ahead and do that first. So we can do that by subtracting 200 from both sides. And notice, if we go to plug these in to the quadratic formula, the numbers are going to be ginormous, and simplifying is going to be a painful process. So before we run the formula, let's see if we can simplify. We can simplify by dividing both sides by 50. Notice all numbers have 50 in common. When we do that, we get x squared minus 7x minus 4, which is far easier to run the formula on. Now we can view this as our a, our b, and our c, and we can run the formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Notice there's not a single x in the solution. It's all numbers, so the quadratic formula will give you a pair of numerical solutions. So we got to simplify this. So 7 plus or minus, that's 49 plus 16. So 49 plus 16 is 65. Does that simplify? I don't think it does. Let me double check. I don't think that simplifies. It does not. So that means we are done. So there's our pair of solutions to this equation. Let's look at one more example. So notice in number 2 here, we have some fractions, and you do not want to input fractions into the quadratic formula. That is some grade A nightmare fuel. It's already difficult enough to simplify. Fractions will make it worse. So what we want to do is go ahead and clear the fractions, and that's something you did all throughout that first homework assignment, so hopefully you're pretty comfortable with clearing fractions by now. I'm going to multiply everything by that least common denominator, so that's 9. So if I multiply everything by 9, I get 3x squared minus 5x plus 18. So that's what we get when we clear the fractions. And we can go ahead and try to factor that. Factoring is going to be difficult, so we'll go ahead and run the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So let's go ahead and start simplifying. I'll start by simplifying what's inside of the square root. So that's 25 minus 4 times 3 times 18, which is negative 191 all over 6. And I believe 191 is a prime number, so I don't think we can simplify that. Let me just double check. Alright, yeah, that's prime, so there's only one step to simplifying. We learned this last section. If you see square root of a negative, pull out the I. So this equation will have a pair of complex solutions. So, nice little tip here. If all else fails, resort to the quadratic formula. The quadratic formula will solve any quadratic equation. Now this begs the question, well, why don't we only do the quadratic formula? Well, it will always work, but it's not always the most efficient approach. So what I typically do is when I'm solving a quadratic equation, I try and figure out if square roots will help me. So if all variables are inside of a squared expression, then the square root property is going to be the bee's knees. But if you see your variables scattered about, then I immediately set to 0. Once I set it to 0, I try to factor it. And if the factoring is difficult, that's when I run the quadratic formula. So the quadratic formula is kind of like the plan B to solving quadratics. So let's go ahead and look at some examples. So what we're going to have to do in this example is factor that third denominator. So that will factor, let me see here, to x minus 2 plus 1. And this is where we're going to go for that common denominator declare. So this is just like we were doing in the first worksheet last week. So we notice this first denominator is missing a factor of x plus 1. So multiply by x plus 1 over x plus 1 accordingly. This one's missing a factor of x minus 2, so multiply numerator and denominator accordingly. That third denominator is fine. So now if we multiply everything by that least common denominator, all denominators clear out. We go and bring everything down. And thus far, you might be thinking, well, we did this last week. Well, you'll notice when we distribute, something's going to be very different here. Notice when I distribute in that first term, I get an x squared. So the x squared tells me I'm dealing with a quadratic, which is very different from anything we did last week. So let's go ahead and try and clean this up a little bit. If I simplify the left-hand side, I get x squared plus 3x minus 4. Nothing to simplify on the right-hand side. And what I'm going to go ahead and do now, square roots are useless. Notice I have x's in multiple terms, so square roots are useless. So if square roots are useless, you're going to go ahead and set to 0. So I subtract 7x from both sides, and subtract 1 from both sides. And then it turns out you can factor. So most quadratic equations in this class you can factor. That'll factor to x minus 5, x plus 1, and you get a solution set of 5 or negative 1. Now you want to be careful here. If we look at the original statement, any solution is okay so long as it's not 2 or negative 1. If it's 2 or negative 1, we get division by 0, which creates undefined values. So if it's 2 or negative 1, we have to throw it out, which means we have to throw that one out because it is extraneous. So there's only one solution that works here, and that one solution is 5. Alright, let's go ahead and wrap up the lecture with one more example. let's go ahead and look at a physics problem. So a ball is thrown upward from a 96-foot rooftop with an initial velocity of 80 feet per second. The distance d in feet of the ball from the ground after t seconds is given by that equation listed there. If you've taken a physics class, that equation will look very familiar to you. So d represents height above the ground, t represents time in seconds. So you just need to plug in the known value. So if we look at part A, determine the height after 1 second, we know the height value is 1 second, that's a time value. So we know the time value is 1, so we set the time value to 1. So we set t equals to 1, and that will tell us what the height value is after 1 second. So type that in. And we get 116 feet. So after 1 second, or 1 second after launch, our ball is going to be 160 feet above the ground. The next question is, when will the ball hit the ground? Well, the ball will hit the ground when its height is at 0. So here we know the height value is 0. So we set height to 0. Now I'm going to go ahead and rewrite the equation in descending order, like you normally would. And you can see here we have a quadratic equation. Now, it's set to 0, so you can run the quadratic formula if you want. I recommend trying to make these numbers a little bit smaller, so let's go ahead and do that. So all these numbers have a common factor of 16, better yet negative 16. I'm going to divide by negative 16. The reason I'm doing that is I want to make that leading coefficient equal to 1. It makes factoring a lot easier. That's 5. T minus 6. Okay, so that does factor. Factors to t minus 6, t plus 1. Therefore, t is 6 or negative 1. The negative 1 doesn't make any sense in this context, so 6 seconds. You know this ball is going to be in flight for 6 seconds. And if you plug in 6, you will indeed get a height value of 0. So last question here. When will the ball be 96 feet high? So that's when we set the height value to 96. So I'm setting the height value there to 96. The time value we don't know, so I'm leaving it as t. So we want to go ahead and set this to 0. So subtract 96 from both sides. And you get 0 equals, I'm going to write this in descending order, negative 16t squared plus 80t. And the trick here is, again, factoring. So like I said at the very beginning of the class, factoring is a very important skill set. So these both have a common factor of negative 16t. So that leaves me with t minus 80 divided by 16. That's what, 5? Yes, 5. Alright, so that tells us t equals 0 or t equals 5. So the ball will be 96 feet above the ground at 0 seconds or 5 seconds. 0 seconds makes sense because it's thrown from a 96-foot rooftop. So at 0 seconds, it's sitting on the 96-foot rooftop. The 5 seconds represents where the ball is on the way down. So if I have my 96-foot rooftop, the ball is going to be at that 96-foot height at 2 different time values, at 0 seconds and 5 seconds. Alright, that is quadratic equations. Again, probably one of the most important sections in this entire course. So please feel free to review your notes, and I will go ahead and throw in some supplemental videos. These are optional, so all the supplemental videos are optional. They're just there in case you need a little bit of extra help. But keep up the hard work, and I've now covered everything that's on worksheet 2. So you are now completely ready to finish up that worksheet, and just let me know if you have any questions. Thank you.